7 is on modeling with equations. So the word modeling in math means story problems. So we're going to do some story problems. Yeah, he's very excited. All right, some of you probably are not very excited. Story problems, I know, are difficult at times, but there are steps to solving them. So first of all, we're going to draw a picture if it's appropriate. We're going to use variables that make sense. So like area is going to be A, base is going to be B, right? We're going to set up an equation with one variable, and then we're going to solve for the variable. Is it what you were trying to find? So the first one is pretty easy. It says in order to rent a U-Haul, you're required to pay a fee of $39.99 per day and 99 cents per mile. You're moving your things from Evansville to Bloomington in one day. The total price when you moved was $173.64. How many miles separate the two cities? All right, so we're going to set it up. Usually what it says at the very end, how many miles separate the two cities, usually in these basic story problems, that is what you're going to let your x or n or whatever be. So we're going to say let m equal the number of miles between those two cities. And if we're moving in one day, we have that flat fee of $39.99 per day. And we're adding on 99 cents for every single mile. So we're going to have 0.99 times the number of miles. And that's going to give us our total cost, which we knew was $173.64. So when I'm subtracting $39.99, yes?
I have a question. So would you, depending on like how many days you have, would you put an X or something next to $39.99?
Yeah, so you probably would know how many days you had. Like it would say like if you did it over 2 days or whatever. But yeah, it could be a two variable thing. But usually two variables, you can't, I mean, every time you have two variables, you have to have two equations in order to solve it. All right, so if I subtract $39.99, I'm really going to subtract $40, and then I'm going to add in a penny. That's the easiest way to do that. So if I subtract 40, I have 133, and then I'm going to have 65. And then I divide out the 99 cents, so a little bit harder to do. So we'll use the calculator. So we get m equals 135 miles. All right. I'm okay if you don't do like a final sentence, but there are some story problems where we're going to need you to write like a final, not a sentence, but like 5% at this price and so on. So in this case, just say 135 and put miles, and I'll know. All right, so I'm sure you guys have seen these ones before. It says the sum of three consecutive integers is 177. Find the three integers. Okay, so there's a couple different ways to do these. So I'll show you the way that you probably learned in Algebra 1. So the way that you probably learned is to let x be the first integer. So we would say let x equal our first integer. So the number after it, so if I'm talking about consecutive back-to-back integers, I would have like 11, 12, and 13, right? Things like that. So if I have x as the first one, then I want one more than that for the next one. So that means x plus 1 is the second one, and x plus 2 is the third integer. All right, so when we add those integers together, we have x was the first one, x plus 1 is the second, and x plus 2 is the third integer. And we get a total of 177. Have you guys all done this before? Yeah. So we end up getting 3x plus 3 equals 177. I subtract the 3 and get 174. So when you do 174 divided by 3, you get 58. So that means your three integers are 58, 59, and 60. Now, I often help with math counts, which is like an 8th grade, 7th and 8th grade competition math. And we never teach it this way in math counts because you have to be like the fastest math student in order to win math counts. So there is a faster way. Does anybody know what the faster way is? Yeah?
Just divide by 3 and take the number below it and above it.
Yep, exactly. So the faster way is to let x be the middle integer. So if x is the second one, then that means x minus 1 is the first, and x plus 1 is the third. So when you add all of those together, x minus 1 plus x plus 1 ends up being 3x, right? So you get 3x adds up to be 177. Oops. And when you divide that out, you end up getting the middle number, which is 59. So then you just have to remember, okay, that's the middle one. And so I have 60 and I have 58. So that's a little bit faster to do it that way. It doesn't matter how you set this up. I'm fine if you do it the other way. All right, so the next one, the sum of 3 consecutive odd integers is 45. So if we have consecutive odd integers, okay, so we're going to, again, let x be our first integer. Well, maybe I should say first odd integer. I'll write odd in there. Okay, so let's think about it. If I had 61, 61 is an odd integer, right? What is the next odd integer?
63.
63. So you have to add 2 to it. Does that make sense? So that means we're going to have x plus 2 is the second odd integer. And then x plus what? 4. Because if I had like 61 and then I have 63 and the next one is 65, I'm adding 4 from the original one, right? So x plus 4 would be the third odd integer. So that means we're going to have x plus 2 plus x plus 4 is equal to 45. So we get 3x plus 6 equals 45. So 3x equals 39. So x equals 13. So that's our first odd integer. So the next one is going to be 2 more, and the last one is 2 more than that. So 4 more than the original. Yes?
How would you do that with the other method?
So if you did it with the other method works best when you have an odd number of numbers, which we do. We have an odd number of numbers, 3 odd integers. So we would make x be the middle one, and then x minus 2 would be the first one, and then x plus 2 would be the third one, right? So you would still get 3x equals 45, so you would get x equals 15 as the middle one, and then you go 2 more before and 2 after to get the other one. All right, we teach you both ways, though, because sometimes you don't have an odd number of numbers, right? And so really it probably would be best to do x plus 1, x plus 2, x plus 3. All right, so same thing here. So if you have 5 consecutive numbers, again, you can make x the middle one. So can you guys do this quickly in your head? Do you guys know what the middle number is? 41, exactly, because you know that 205, if you divide it into 5 pieces, it goes in 41 times. So 41's the middle, so then you're going to have 40 and 39, and then you're going to have 42 and 43. So see how you can quickly do these in your head if you know that trick. So let's say we let x be the middle. That means we would have x, so that's the middle one. We're going to have x minus 1 and x minus 2. We're going to have x plus 1 and x plus 2. So if you want to see what those 5 numbers are. So if you don't want to set it up that way, it's fine. Put x as your first one, then you're going to have x plus 1, x plus 2, x plus 3, and x plus 4. All right, so we get a total of 205, and this adds up to be 5x. So like Jacob said, we have x is equal to 41. So if that's the middle number, then we have 42 and 43, and we have 40 and we have 39. Those are our 5 integers. So you always have to be careful if you're doing like online homework or something. So when you go to college and you have online homework, maybe it says find the 4th number, right? You just have to be very careful. They'll do that on the SAT as well, where you like find the first one and you're like, oh, I got the first one is 39. And then it's like find the 5th number, and you fill in the wrong circle just because you're in a hurry. All right, so here's another one. So a pasture is twice as long as it is wide. Its area is a total of 115,200 square feet. So how wide is the pasture? What are the dimensions of the pasture? So when I say twice as long as it is wide, the wide is what I'm going to let my variable be. So whenever I say twice as long as something else, make the as part the variable. So we're letting w equal the width, because that means 2w is equal to our length. So we're going to have 2w and w. So my area is 115,200 square feet. And we know in order to find the area of a rectangle, we do the length times the width, right? Base times height. So we're going to do 2w times w equals 115,200. So if I simplify the left side, 2w times w is 2w squared. So when I divide by 2, I end up getting w squared is equal to 57,600. And I solve by taking the square root. So if you have a square, you do the opposite operation. Do you guys all know this? And we take the square root of both sides. Now, whenever you take a square root, you really should do plus or minus. But this is a story problem, and this w is a length, like the width, right? So you're not going to get a negative 240. You're only going to have a positive amount. So our width is 240. Now the second question says, well, what are the dimensions of the pasture? So our dimensions, remember dimensions we always say like 4 feet by 2 feet, right? We say like a length and a width. It doesn't matter what order you put it in. So if we have 240 is the width, then what's our length? Right, it's 2w. It's 480 exactly. So we'd plug in to get that. All right, so make sure you answer all of the questions. All right, feeling good about these basic story problems so far? Do you like when I ask that? Because you always know it's going to get harder when I say things like that. Oh, part of this got cut off. All right, I can't remember what it said, so let me... Okay, so it's talking about a picture frame, right? Let me see if the next page is better. Sometimes I do it again. Oh, nope. I just cut it off completely. All right, so we have a picture frame. And it's made to display an 8 by 10 photograph. And the frame is a uniform thickness around the 4 edges. So do you guys understand what I mean by uniform thickness? Yeah, it's the same like width all the way around. All right. The perimeter of the frame is 2.5 times the perimeter of the photograph. What is the thickness of the frame? What are the dimensions of the frame? Okay, so our perimeter of the frame is 2.5 times the perimeter of the photograph. So when you have these frame problems, so we don't know how thick this frame is, like how wide the frame is. So we're going to call it x. So we're letting x equal, I'm calling it the thickness of the frame. In the past, I've called it the width, and that's confused people, so the thickness of the frame. Okay, so we're going out a distance of x in every direction. So we want to know what this whole distance is. So originally it was 10, but we've added x on both the top and the bottom. So what do we get? 10. 10 plus 2x, yeah. And then the same idea here, we had 8 before, but now we've added x on the right and the left. Okay, so it's going to be 8 plus 2x. So let's talk about, sometimes, you know, it kind of helps if you just, so the perimeter of the frame, we'll talk about each of these, and the perimeter of the photograph. So the perimeter of the frame is going to be 10 plus 2x plus 8 plus 2x plus 10 plus 2x plus 8 plus 2x, right? You're going to add all 4 sides. Now you could double each of those. You could say 2 times 8 plus 2x plus 2 times 10 plus 2x. I'll write it out how I just said, though. 8 plus 2x plus 10 plus 2x plus 8 plus 2x plus 10 plus 2x. Was going to be sneaky. All right, so we get a total of how many x's? So we had 18 plus another 18. No, not x's. So 2x, 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 2x. So 8x. And then we had 18 plus 18, so plus 36. Did you guys get that for the perimeter of the frame? And our perimeter of our photo, what's it going to be? Yeah, 8 plus 10 plus another 8 plus 10. So we get a total of 36. All right, so sometimes it helps if you kind of write some background information. We're not putting together the equation yet. We're just figuring out what each of those is. So we simplified each of them. So we know that the perimeter of the frame, so this 8x plus 36 is, so in math is means equals. Yeah, cool.
Could you have just done the perimeter of the photo and then known to add the
Yep.
8? Okay.
So the perimeter of the frame is going to be 8x plus 36, and it says is 2.5 times the perimeter of the photograph. So we're going to do 2.5 times 36. So that's our equation. So we do 2.5 times 36, and we get 90. We subtract over the 36, and we get 54. So x is equal to 6.75 inches. That is the thickness of the frame. This is one of those obnoxious frames, have you guys ever seen these frames, where we have a photo and then the frame is like really big around it. It's pretty big. All right, so what are the dimensions of the frame then? Well, the dimensions of the frame, we're going to put 6.5 or 6.75 into the 10 plus 2x, so we're putting it in here and here. So we have 10 plus 2 times 6.75. So we get a total of 23.5. And we do 8 plus 2 times 6.75, and we get 21.5. So our dimensions of the frame are 23.5 inches by 21.5 inches. So we've answered all the questions. Okay, would you be able to do that on your own? Possibly, hopefully. Definitely getting a little bit harder, right? All right, so the next one kind of takes you back to geometry. Now, all of you guys should know how to do this with your geometry skills. Some of you guys are doubling up. Maybe you don't know if you're doubling up. All right, so Jake wishes to find the height of a 3-story building. He is 6 feet tall. He measures his height and finds it to be 3 feet long. The building's shadow at the time of the day is 18 feet long. Find the height of the building. Have you guys seen these before? So you have a building and then you have him. And the sun's up here and it's shining down. And they each have shadows. So he measures his shadow and finds it to be 3 feet long. And he measures the building's shadow and he sees that it's 18 feet. He is 6 feet tall, and we want to find the height of the building. So we're letting h equal the height of the building. All right, do you guys know right away what it is? Karen, do you know what it is? Yeah? Yep, it's 36. Good. All right, now you can kind of see because his height is 6 and his shadow's height is only 3. It's half of that, right? So that means the building is going to be 36 and half of that is going to be the shadow. It's a similar triangle. So you set it up as like height of the building over height of the person equals shadow of the building over shadow of the person, something like that. Or you could do like building on one side, person on the other, like height of building over shadow of building equals height of person over shadow of person, right? Doesn't matter how you set it up. So you can cross multiply and you'd have 3h equals 18 times 6, which is kind of hard to do, yeah, without a calculator. And then when you divide by 3, you do get 36. Or whenever I have proportions, I just say, oh, I multiply by 2 here. I'm going to have to multiply by 2 here to get the other one. So I kind of think, how do I get from one number to the other number? So you can do that as well. All right, do you guys remember similar triangles now? Are you like, oh, man, didn't know that would come back. I don't know why I'm misspelling feet right now. Feet. All right, so here we go. So it says 2 cyclists 90 miles apart start riding towards each other at the same time. One goes twice as fast as the other. If they meet 2 hours later, at what average speed is each cyclist traveling? All right, so they're 90 miles apart from each other. And one is going twice as fast as the other. Okay, so we're going to break it up like that. All right, if they meet 2 hours later, at what average speed is each cyclist traveling? Okay, now some of you guys might be able to figure this out. Yeah.
One going 30, one going 15.
Okay, good. So how did you get that, Eric?
Because if they're 90 miles apart, one going twice as fast as the other, that means that by the time the first one gets to 60 miles, one will be 30.
Yeah, good. So he just kind of logicked through the problem. Do you guys understand that? So we know that the distance is equal to rate times time. So if we have a total distance of 90, and we're going for 2 hours, the distance over the time is equal to the rate. So we want to know what distance each person is going. So let's go ahead and, hang on, let me write this a different way. So let's let rate R equal the rate of, let's say, the slower cyclist. Then the rate of the other one is 2R. So I shouldn't say distance over time equals rate. Let's just talk about the distance. So the distance is equal to the rate times the time. So that means that each distance that they're going, the first cyclist is going a total distance. So the slower distance equals 2, right? 2 hours times R. And the faster distance equals 2 times 2R, which is 4R. So this distance is only 2R, and this one is 4R. So we get a total of 6R is equal to 90. So the slower rate is 15 miles per hour. So it's tricky. It's almost easier just to think through the problem and say, okay, if I'm going twice the distance, you could just solve it with distances. And you could say, okay, if I'm going a total of 90 and I divide it into 2x plus 1x, I have 3x. The first person goes 30 miles and the other one goes 60 miles, right? You can do it that way. And then you can say, oh, well, if they're going for a total of 2 hours, what's their rate then? It's going to be half that. So you could do it that way as well. So your rate ends up being 15 miles per hour and 30 miles per hour. All right, so you might also have ones that are pretty simple like this. So 4 more than 2/3 of a number is 44. This is just using your math skills, like recognizing what is, means in an equation, and so on. So when it says 4 more than, so 4 more than 2/3 of a number, so 2/3 x, is means equals 44. So we write it like that. So we're letting x equal the number. We subtract the 4 over, we get 40. We want to get rid of a 2/3, so we multiply by 3 over 2. So we end up getting x is equal to 60. So 60 is the number. I heard someone say that. You were speedy. Okay. All right, and then other things where we have like a rate of change. So it says a 1,000-gallon aquarium now holds 240 gallons of water. Okay, how long will it take to fill the aquarium if the water is entering at 25 gallons every minute? So we're letting x equal the time to fill in minutes. All right, and how much are you filling? Yeah, Eric?
I think that's still 760.
Yep, exactly. So you have a 1,000-gallon tank, but it's already at 240 gallons. So if we have a total of 1,000 gallons, how much do we need to fill? Yeah, we need 760. Now you could work that into your equation, or you could just start with 760. So when you talk about the water entering 25 gallons per minute, let's think about it. After 10 minutes, how much would I gain? 250 gallons, right? Does that make sense? 25 gallons every single minute. So that's how we're going to set it up. So we're going to say we have 25 gallons every single minute, so 25x, and we want that to total 760. So you could write plus 240 equals 1,000 if you want, or you could have simplified the equation first and realized that you needed 25x equals 760. Do you guys get both of those? So when you divide by 25, we get x equals 30.4. So 30.4 minutes. What if I asked you how many minutes and how many seconds? What would you do to get the number of seconds? Yeah, take that 0.4, just the 0.4 part, and multiply by 60, and you get 24. So you could say, or 30 minutes and 24 seconds, right? Because 0.4 minutes, in order to find how many seconds it is, you multiply by 60 seconds. All right, still feeling good about these? All right, let's try a couple more. All right, so Ariba has 5 more than Chloe, and Chloe has 11 more than Bronwyn. The three of them have $45 total. How much does each have? All right, so when I say more than so-and-so, and then I say more than so-and-so, I'm going to go with Bronwyn as being the person that I'm making my variable. So we're going to let B equal the amount that Bronwyn has. That's a $sign. All right, so if B is Bronwyn, what's Chloe? 11 plus B, or B plus 11. And what's Ariba? 5 more than Chloe, so it's 11 plus B plus 5, which is B plus 16. Do you see how you can kind of organize your thoughts off to the side? So we set it up, and we know that we have Bronwyn's amount, we have Chloe's amount, and we have Ariba's amount. And that's going to be a total of $45. So we had 1, 2, 3. So we have 3B plus 27 equals 45. Subtract over, and then divide by 3. Yeah, I don't know why I took my calculator out. So B equals 6. So Bronwyn has $6. And this is where you would want to write like an end statement, right? Chloe has 11 more than that, so 17, and then Ariba has 5 more than that, so 22. Okay. All right, the next one. So it says, on the first of 3 Algebra 2 tests, a student scored 72 points. He scored 1 more point on the third test than he did on the second test. So notice how we're saying than he did on the second test. That's when I would let my second test be what my variable, okay? His average on all 3 tests was 83. What was his score on each test? So we're letting x equal score on second test. So then on the third test, he scored 1 point more, so x plus 1 equals third test. And what do you get on the first test? 72, right? So we're going to say 72 plus x plus 1. And we want to average it to get 83. So what do I do to find an average? Yeah, I'm going to divide all of that by 3, and that gives a total of 83. So I have 73 plus 2x over 3 equals 83. So I'm going to multiply that 3 over. So I have 83 times 3, so I get 249. And then I'm going to subtract the 73 out. So I get 176 and divide by 2. So I have 88. So what was his score on each test? The first one was a 72, the second one was 88, and the third one was 89. Okay, makes sense? All right, the ones where they talk about like dimes and nickels, dimes and quarters, and so on. So it says, how many nickels does she have? So we're going to say, let n equal nickels. All right, so then when we talk about the number of dimes, we want a total of 42. So if she had, for instance, like 10 nickels, she would have 32 dimes, right? So our dimes are going to be 42 minus n. And then we want to talk about their value. So we want to get a total of $3. So every single nickel is worth 5 cents, right? So 0.05. And every dime is worth 10 cents. So we're going to do 42 minus n. And we get a total of $3. So we just distributed n, so 0.05 n plus 4.2 minus 0.10 n equals $3. So when I do 0.05 minus 0.10, I get negative 0.05 n. And then when I do 3 minus 4.2, I get negative 1.2. So when I do negative 1.2 divided by 0.05, negative 0.05, I get n equals 24. So that means that my number of nickels, I have 24, and my number of dimes is going to be 42 minus that. So 42 minus 24 is going to be 18. So that's our answer. All right, good so far? So you're going to have lots of different story problems. So hopefully you've done a little bit of these now for one. All right, now the last type that we're going to talk about are mixture problems. Okay, and I have a very specific way that I do mixture problems. I think it helps students. So I use like little jars. So we do like little drawings. All right, and we're going to set up the picture using jars, and we're going to put the percent inside the jar. If it says pure, it's going to be 100% of whatever you have. If it says water, it's 0% of whatever you have. Like 0% fruit juice is water, right? 0% acid. 0% antifreeze. There's lots of problems like this. All right, so Mrs. Adams wants a 50% acid solution, but she only has 20 and 75% solutions. How much of the 75% must she mix with the 20%, or 2 liters of the 20%, to get the 50% she needs? So I always set it up with little jars. You don't have to draw it as fancy as I draw it. You can draw like little rectangles or squares if you want. But inside here, I put my percentages. So if you want a 50% acid solution, I'm going to put, let's see, she has 20% and she has 75%. Now notice how I'm writing them, 0.20, 0.75. That's how we write percents in math. We want to get a 50%. How much should she mix with 2 liters? I put the amounts down here. These always add up. Okay, give me just a second. We'll finish this up. So if we have 2 liters of the 20% and then we don't know how much of the 75%, so we have X. Think about liters. If I have 2 liters of something and I add it to X liters of something else, how many total liters do I have? 2 plus X, right? If I had like 2 and 3, I would have a total of 5. That's why these ones always add up. Percents will never add up. You can't add something that's 50% to something that's 50% and get something that's 100% of something. It's still 50% of whatever it was. Okay, now that we have that, we multiply. So we multiply here and here, here and here, here and here, and we set up our equation. So we're going to get 0.20 times 2 plus 0.75 times x equals 0.50 times 2 plus x. And then we solve for x. So you don't have to write all this. I'll do it really quickly for you. So did I mess something up, maybe? Oh yeah, 0.6. I think I'm good. So 0.6 divided by 0.25. So x equals 2.4 liters. So you're adding 2.4 liters of the 75% acid. All right, does that make sense? So if you have trouble with those on your homework, that's fine. I will help you with the mixture ones. But go ahead and start out. The bottle contains 750 milliliters of fruit punch with a concentration of 50% pure fruit juice. Adriana drinks 100 milliliters of the punch and then refills the bottle with an equal amount of the cheaper brand of punch. If the concentration of the juice in the bottle is now reduced to 48%, what is the concentration of the punch that Adriana added? So we're going to draw our bottles. And inside I'm going to have my percentages. So you started out with 50% fruit juice. So this inside is going to be percent fruit juice. You don't have to write this, but kind of for you. Okay. And originally she had 750 milliliters of that. Okay, she's going to drink 100 milliliters of the punch. So I guess now she doesn't have 750 milliliters. How much does she have? 650. And then she refills the bottle with an equal amount of the cheaper brand of punch. So if she's going to refill the bottle, how much is she adding to it? 100, right? Okay. We don't know the concentration of that cheaper brand, but now it says the concentration of the juice in the bottle is now reduced to 48%. Does that make sense? It's like more watery. There's not as much like fruit juice in it. So she's kind of watered it down. And she now has a total of 750 milliliters, right? So these amounts down here should always make an equation. So see how 650 plus 100 equals 750. That should always happen. Like this should add up. Okay. Then it says, what was the concentration of the punch that Adriana added? So that's going to be X. So the way these problems work is if you had 650 milliliters of this fruit punch mixture and 50% of it was actual fruit juice, how many milliliters was actual fruit juice? 325, exactly. Do you guys understand that? You had 650, 50% is actual fruit juice, the rest of it's just kind of watery. So it'd be 325. All right, so that's what we're doing to set up the equation. We're saying we had 0.50 times 650. Oops, not 620, 650. That's going to be the amount of actual fruit juice we have. Plus 100 times X equals 0.48 times 750. So this equation is telling you the amount of fruit juice. So you have a certain amount of fruit juice plus another amount, and it equals the total amount. All right, so go ahead and multiply out and solve. So you get 325 plus 100x equals 0.48 times 750 is 360. Subtract the 325 over, you get 35. So 100x equals 35. So x equals 0.35. So think about what this means. If it's 0.35, what percent of fruit juice is it? 35%, right? And that's your answer. Okay, all of these work the exact same way. So it always helps when you draw the little buckets or jars. That way you know, okay, percentages go on the inside, numbers go on the outside. All right, so Miss Summit, I should change that to Mrs. Mann now, shouldn't I? Has two brine solutions, one containing 5% salt and the other containing 20% salt. Okay, so the percent that we're talking about is salt. So that's what's going to go on the inside. So 5%, so 0.05, not 0.5, right? 0.5 is 50%. And 20%, 0.20. How many milliliters of each should she mix to obtain 1 liter of 14%? Well, this one's a little tricky because now we're missing two values. Okay, I know in the bottom that my amounts have to add up. So I can let x equal either one. So I'm going to let x equal the percent, or sorry, not the percent, the amount of the 5% salt solution. So I'm going to put x here. Now I guess it is saying milliliters, so we should kind of be careful. So instead of one liter, what should I really put? Do you guys know your milliliters to liters? 1,000. Milli means 1,000. So I'm going to cross that out and put 1,000. All right, so let's say I have 400 for x. So 400 for the 5%. Then what do I have to have for the 20%? If I had 400 for x, 600. Or 600. They're going to add up to be 1,000, right? So 400 and 600 make 1,000. It's because I have an actual amount of a substance. If I have a certain number of milliliters plus a certain number of milliliters, it's going to equal that 1,000 milliliters. Right? So if I have x, then this is going to be 1,000 minus x. You can always kind of check that. See those amounts on the bottom? You have x plus 1,000 minus x. That just equals 1,000. This should work out. Okay, now set up our equation. So we have 0.05x plus 0.20 times 1,000 minus x equals 0.14 times 1,000. If you didn't notice, switch it to milliliters. It's fine. You just have x and 1 minus x for your amounts. And in the end, you know you have liters, so then you need to convert to milliliters. Okay, multiply out. So 0.05x plus 200 minus 0.20x equals 140. If you have 0.05 minus 0.20, that's negative 0.15x. Subtract the 200 over. So 140 minus 200 is negative 60. So negative 60 divided by negative 0.15. So you get 400. Oh, I just guessed earlier. I didn't know it really was 400. All right, so that's 400 milliliters. Now, when you have a question like this where it asks for each one, though, make sure you don't just circle 400 milliliters and think that you're done. You kind of have to write. You have to say 400 milliliters of the 5%, and then the other one would be 600. So 600 milliliters of the 20%. So you have to write both answers. Okay, is this kind of making sense? Understand? Okay, here's a good one. All right, it says the radiator in a car is filled with 60% antifreeze and 40% water. It is recommended to have the concentration of antifreeze in the summer at 50%. If the capacity of the radiator is 3.6 liters, how much antifreeze needs to be drained and replaced with water to reduce the antifreeze concentration? So it's at 60%. We want to dilute it to 50%. Okay, so let's go ahead and draw our little buckets. Whenever I have something that says drained, I don't really draw the minus the bucket. You know, you can, but I just kind of think about it. So it's originally 60%. So we're talking about the percent of antifreeze. Okay, I'm going to drain some of it out. So I originally started with 3.6 liters, but I'm going to take some out. So it's still at 60%. And I'm going to add in water. So if I have water, what percent antifreeze is it? What do you hope that it is? 0. You don't want any antifreeze in your water, right? That would be bad. Okay, so it's going to be 0%. All right. You're going to add a certain amount, and you're going to get 3.6 liters back. We want it to be 50% then. It says how much antifreeze needs to be drained and replaced, so that's going to be our x. So what goes underneath the 0.60 then? You need those amounts to add.
enjoying breakfast with them.
I got here almost on time. What did we put underneath? 3.6 minus x. Right? Do you see how those amounts add? 3.6 minus x plus x ends up being 3.6. Okay, that's how you can kind of check. You could also think of it logically, like if I had 1 liter of water that I'm adding, that means I had 2.6 for the original. You can think of numbers. All right, now these problems are good. Notice how I had 0 for an amount. You could also have 1 for an amount. So think about when I would need 1. So if I'm talking about like pure orange juice or something, I think you have something like that in your homework. If I'm talking about pure orange juice, so I start with like a diluted brand, so a cheap brand of orange juice that has a lot of water in it, and I want to increase the percent orange juice, I could add in what's called pure orange juice. If it's pure orange juice, what percent orange juice would it be? 100%, so you put 1. So sometimes you'll have pure something, like I want to add in pure whatever. Pure antifreeze, you could have that. That'd be 1. The percentage would be 1, so you might want to write yourself a little note to remember that. All right, so I have 0.60 times 3.6 minus x plus 0x, so that goes away, equals 0.50 times 3.6. So I get 2.16 minus 0.60x equals 1.8. 1.8 minus 2.16 gives me negative 0.36. So I have negative 0.60x equals negative 0.36. You stuck, Melvin? You got it? So you get x equals 0.6. Okay, so it's 0.6 liters that you're draining out and then replacing. You feel pretty good about the mixture problems? You think you can handle it? They're not too bad. All right, job sharing. So we've done these before, so this should kind of be a review. So it says find the fraction of the job that can be completed by each person in 1 hour, 1 minute, or whatever time you're talking about. Add the fractions for each person.